Hello everyone, my name is Christian Jimenez. In this video, I will explain point 1 of the assignment. In this point is about magnetic flux and induced electromotive force in a simple motor. First, I will present the given data. The radius of the coil is 0.18 meters. The area of the coil is A equals P times R squared. So after replacing the radius value, the area is 0.1018 square meters. The magnetic field vector is vector B equals 2 times 10 to the minus 3 A hat plus 7 times 10 to the minus 3 J hat plus 14 times 10 to the minus 3 K hat Tesla. And the frequency is 73 Hertz. Now I will calculate the magnetic flux. The magnetic flux equation is phi sub p equals vector b dot vector a. Since the area vector points in the c direction, only the k component of the magnetic field is used. So the magnetic flux becomes phi sub p equals v times a. Replacing the values is phi sub b equals 14 times 10 to the minus 3 multiplied by 0.1018. The result is P sub B equals 1.43 times 10 to the minus 3 Weber. Now, this is the magnetic flux for 1 turn. For the total flux is V total equals N times V sub B. Replacing the values, the result is V total equals 3.71 times 10 to the minus 2 Weber. Now, the angular velocity equation is omega equals 2pf. Replacing the frequency, the result is omega equals 458.67 radians per second. The magnetic flux as a function of time is V sub B of t equals n times b times a times cosine of omega t. Now replacing the values, the result is V sub B of t equals 3.71 times 10 to the minus 2 times cosine of 458.67 t. At time equals to 0 seconds, the flux is maximum. Finally, I calculate the induced electromotive force using Faraday-Lenz law. The equation is epsilon equals negative dV sub B over dt. After taking the derivative, the equation becomes epsilon of t equals n times b times a times omega times sin of omega t. Replacing the values, this is the result. Epsilon of t equals 17.0 times sin of 458.670 volts. The maximum induced electromotive force is 17 volts. The negative sign means that the induced voltage opposes the change in magnetic flux. This completes the exercise. Thank you for watching.